Level 0, the silent ones. Earthquakes happen everywhere. Dozens every single day, in fact. Most people never know about them because they change nothing. They rattle nothing, destroy nothing, warn nobody. At this starting point, we're dealing with seismic activity below magnitude 6.5, and here's the thing. The ground can shake violently without the ocean caring one bit. These quakes either bury themselves so deep they never reach the seafloor, or they rupture so far from any water that displacement is mathematically impossible. The rock moves. Energy radiates outward, but the water column stays put. Now, underneath all that silence, instruments are working. Deep ocean sensors are recording whispers. Satellites overhead are picking up millimeter-scale ripples traveling across the Pacific at 500 miles per hour. Waves so small that a boat would never notice, yet so consistent that machines can track them across entire basins. This is the ocean's baseline noise. But here's what makes level 0 genuinely unsettling. Sometimes the tremor that precedes the deadliest tsunami in a decade is classified as one of these nothing events. The ground shakes, scientists noted. Life continues. Then weeks or months later, or sometimes just hours, the real rupture happens. The early quakes weren't harbingers. They were warm-ups. They were the earth loosening the hinges before it swung the door wide open. Level 1. Detectable but deniable. When you cross into magnitude 6.5 to 6.9 territory, the ocean finally responds with something real, not just instrumental noise. The seafloor is shifting now. There's actual vertical displacement of the rock, and that's what matters for tsunami generation. But the volume of water being moved is still modest, enough to create a disturbance, not enough to create a catastrophe. What emerges are anomalies. Harbors report strange currents. Buoys record unexpected sloshing. Tide gauges go haywire for a few minutes, then return to normal. The genius of these level 1 events is that they're visible only to people looking. A fishing boat in the right place at the right time will suddenly lurch. The captain notices something's off, maybe reports it, and then everything settles. A beach observer might see the water pull back further than usual, or advance a bit more, creating what locals call weird tides. To most people, it's curiosity. To geophysicists, it's a test run of the warning system. In Japan, Chile, and Indonesia, authorities still take these seriously. Protocols activate. That's because the same measurement systems that detect a magnitude 6.8 disturbance are the frontline defense against a magnitude 9.0 catastrophe arriving in an hour. If the instruments fail on Tuesday for a minor event, they might fail on Wednesday when it actually matters. Level 2. The first real casualties. Magnitude 7.0 to 7.2 events sit in a dangerous gray zone. They're big enough to do damage. They're not big enough that everyone knows they're coming. A rupture at this scale is usually close to the coast and shallow, maybe just 10 to 30 kilometers down. When you get that combination, the seafloor displacement goes from millimeters to meters. Water that was sitting at one elevation is suddenly sitting at a different one, and physics demands it equalize that difference immediately. The resulting wave is typically 10 to 20 feet high by the time it approaches land, and it moves faster than any normal ocean wave. Here's the cruel part. The communities closest to the epicenter experience almost no warning. In 2006, West Java was hit by exactly this scenario. A magnitude 7.7 earthquake, slightly above this level but illustrative, off the coast triggered waves that were only 6 to 8 meters at peak, but they came with no earthquake sense to forewarn people because the rupture mechanism was inefficient at radiating seismic energy. It just dumped energy into water displacement instead. Over 650 people died, many of them tourists at beach resorts who had no evacuation procedures because their region had never trained for this scenario. The wave isn't a wall you see coming from miles away. It's a surge that arrives fast and hits like a moving flood. It's not the height that kills, it's the momentum and the debris. Level 3. Crossing political boundaries. Magnitude 7.3 to 7.5 earthquakes create what we might call regional tsunami emergencies. The rupture now extends for 100 to 200 miles along the seafloor, generating waves that radiate in all directions with significant energy. A single earthquake of this size puts multiple countries on alert simultaneously. Wave heights can reach 30 to 40 feet depending on local underwater topography. You're now talking about destruction that spans coastlines, not just individual beaches. In 2023, the Loyalty Islands experienced exactly this when a 7.5 magnitude quake struck nearby. Multiple island nations across the South Pacific received tsunami alerts, and even though casualties were limited by sparse population, the reach was undeniable. What makes Level 3 genuinely challenging for emergency response is the multi-wave phenomenon. The first surge arrives, causes immediate damage, kills people caught in the open. Then, 30 minutes later, sometimes an hour later, another wave comes through, often larger than the first. Rescue crews that moved into affected areas after Wave 1 are suddenly back in danger. Communication systems are down. Roads are destroyed. Coordination between countries becomes impossible. Level 4. Multinational Crisis Response. Magnitude 7.6 to 7.9 earthquakes create situations where one nation's disaster becomes all neighboring nations' disasters within minutes. The 2001 Peru earthquake measured 8.4, well above this threshold, but it exemplifies the pattern perfectly. The tsunami didn't just slam Peru, it reached Chile over 600 miles away, with waves damaging ports, destroying fishing infrastructure, and killing people in both countries. The international nature of the disaster means resources become stretched thin across borders. Chile's emergency teams are busy with their own coastline while trying to coordinate with Peru. The United States is monitoring its Pacific coast. Mexico is on alert. It's an orchestrated symphony of emergency response, and if any part breaks down, people die. Waves at this level typically exceed 30 feet and arrive with enough force to penetrate inland for hundreds of meters. Entire towns vanish in 10 minutes. The surge is so sustained that rescue attempts are impossible for the first several hours. People are just trying to survive, not help others. Level 5. Continental Reach. Delayed Impact. Magnitude 8.0 to 8.4 earthquakes open a new dimension of tsunami threat. The transoceanic wave. You can be standing on a completely different continent, feeling no earthquake at all, living your normal day, and then the ocean starts behaving strangely. The water recedes further than it should, or pushes in higher than usual. Hours after the quake that caused it, people 2,000 miles away are suddenly in danger with almost no warning because they didn't feel the initial shock. The 1946 Aleutian Islands earthquake, magnitude 8.6, is the textbook example. Alaska ruptures, and hours later, Hilo, Hawaii, gets hit with waves exceeding 50 feet high. Over 150 people were killed in a city that had no direct connection to the earthquake other than being downstream from it. The challenge for emergency managers is obvious. How do you evacuate a place for a tsunami originating from an earthquake felt on the other side of an ocean? Level 6. Basin-wide tsunami. Magnitude 8.5 to 8.9 events start breaking systems. The rupture zone now extends 300 to 400 miles along the seafloor. The amount of water displacement is entering the realm of incomprehensible for most people. At this scale, waves radiate at 400 to 500 miles per hour. They don't look like waves in deep water. They look like broad swells a few feet tall. Then they hit the continental shelf, slow down, and compact. That's when a 3-foot deep ocean wave becomes a 20-foot coastal surge. Countries that are geographically unrelated to each other suddenly share emergency response operations. Japan activates its protocols. The U.S. West Coast mobilizes. Chile wakes up. Simultaneously, because the wave just keeps coming, arriving at different places at different times over the course of a day. The 1868 Arica earthquake, estimated between 8.5 and 9.1, devastated southern Peru and Chile with waves reaching 52 feet in some locations, then traveled across the Pacific to damage Hawaii, Australia, and New Zealand. Over 25,000 people died in the initial earthquake and tsunami impact zone. Level 7. The monster events. Magnitude 9.0 and above are the category where entire ocean basins respond. The 2004 Indian Ocean earthquake was 9.1. The rupture stretched for over 800 miles along the seafloor. The tsunami it generated wasn't just a surge, It was a tidal force that moved through multiple ocean basins sequentially, hitting a dozen countries and circling the globe. Over 227,000 people were killed or went missing. The waves didn't just flood coastal areas. They carried boats inland for miles, deposited cargo containers in the middle of cities, reshaped coastlines permanently. Then 2011, Tohoku, Japan. Magnitude 9.0 off the northeast coast. Waves exceeded 120 feet in some valleys and bays. Over 18,000 people died. The tsunami overtopped seawalls that engineers had believed were sufficient, flooded the Fukushima nuclear facility, disabled backup power systems, and triggered a nuclear disaster that contaminated an entire prefecture for decades. At level 7, you're not measuring the disaster in hours or days. You're measuring it in years of recovery, ecosystems that take decades to regenerate, economies that never fully bounce back. Level 8. When volcanoes do it. Not every tsunami comes from earthquakes. Sometimes it comes from underwater explosions. The 2022 Hunga Tonga eruption in the South Pacific wasn't a slow subduction zone rupture. It was a volcanic explosion with the force of hundreds of nuclear bombs happening underwater. The tsunami it generated didn't behave like typical earthquakes. It was coupled with an atmospheric pressure wave that traveled at the speed of sound. The combination meant waves arrived in Japan, Chile, and California with almost no warning because traditional seismic networks were looking for different signatures. Volcanic tsunamis are uniquely dangerous because they can form multiple ways: an island face collapsing, pyroclastic flows boiling the ocean, sudden pressure release from an erupting magma chamber. And unlike earthquake ruptures that take minutes to complete, an eruption-triggered tsunami can arrive in seconds if you're close enough. That compressed timeline makes evacuation nearly impossible. Level 9. The tallest waves ever seen. The deadliest tsunamis come from earthquakes. The tallest tsunami ever recorded came from a landslide. In 1958, an earthquake in Lituya Bay, Alaska, magnitude 7.8, triggered a rockslide. About 30 million tons of rock suddenly dropped into a narrow inlet. The water displacement was so violent and so confined that it created a wave reaching 1,720 feet high. Higher than the Empire State Building, higher than any structure on Earth except skyscrapers and mountains. Only 5 people died because almost nobody lived there. If the same event happened in a populated fjord in Norway or Chile, the death toll would be in the thousands. Landslide tsunamis don't travel far, but they obliterate everything nearby with almost no warning. Level 10. The theoretical extreme. There's one more level. Events so rare and so catastrophic that no human has witnessed one in recorded history. Yet geologic evidence suggests they've happened before. Cumbre Vieja in the Canary Islands has been proposed as a potential mega-tsunami source, a theoretical scenario where a massive flank of the volcano collapses into the Atlantic, generating waves hundreds of meters high that could affect the Americas. Later research has downgraded these predictions significantly, suggesting multiple smaller failures rather than one cataclysmic collapse, and thus smaller tsunami waves than originally modeled. Other possibilities include massive glacier calving events in Greenland or Antarctica triggered by rapid climate change, creating local mega-tsunamis without warning. These aren't science fiction. They're physically possible, documented in ancient sediment records, and part of Earth's long-term hazard profile. At level 10, conventional defenses fail. No warning system works fast enough. No barrier holds. It's nature in its most extreme form. If you want to understand what the planet's actually capable of, hit that like button and subscribe. We'll keep pulling back the curtain on the dangerous stuff.